also have a farm in the south of Portugal, and in that context I have worked with the Associação Terra Sintrópica. I invited them to present at the training school in Lisbon for the NEXUSNet. And after that, the invitation came that they would come here and present their project to you. Unfortunately, they could not travel this week because they had other plans, and I said, well, I'm going to be there anyway, so I will present for you. But I am not actually a specialist in governance, or, I'm an environmental economist. That's what I do. I'm coming to tell you, no, you can ask me questions and I will try to tell you as much as I know from the work that I've done with them, but just to make it clear that I'm going to give you a short presentation on what it is exactly that syntropic farming is and what Terra Sintrópica is trying to do in the south of Portugal. The title of the presentation is Planting Water, the Art of Harvesting the Sun. So it kind of mixes water and energy and food because we're doing it to produce food. So we will explore 3 issues, 3 challenges, and 1 strategy in this presentation. Wait, sorry, I did not mean to do that. So the 3 issues that we've all talked about and are very conscious of are water scarcity, especially in the Mediterranean basin, which is what the focus of this forum this week. Water scarcity, desertification of the land, and loss of food sovereignty. We understand that food sovereignty is a goal in the context of, maybe there's something unexpected coming on and we need to have some percentage of our food needs to be produced nearby. Doesn't have to be everything, of course. And what are the 3 challenges we propose to face those 3 issues? So first, we have to restore the water cycle on our lands, we have to rebuild the soil's carbon sponges, and we have to maximize photosynthetic production of our plants. So let me tell you some words about each one of these, and then I will present the case study on location. This is the strategy that I will present to you. So the water cycle, we now understand more and more that it's actually a living, breathing cycle. So the trees, the living beings, the trees and the terrestrial ecosystems are an essential part of getting the water to move in the atmosphere. Water is not just evaporating in the oceans and the rivers. Water is being moved by trees and other plants that are breathing water. And this creates the conveyor belt that leads water through the continental systems to the different places inland. We always knew that plants needed rain, but now we wonder if maybe rain needs the plants. If we want to have rain, we need to have plants. We need to have trees in particular. So it's a whole new paradigm, and that's what we mean by saying we need to plant water. We need to have the living plants to breathing water for the water to be moving inside our lands. The second aspect is the soil carbon. We know that plants capture carbon dioxide and then they pump down the carbon in their roots, and that feeds the microorganisms in the soil. And the more carbon is in the soil, the more organic matter is in the soil, the more the soil can act as a sponge, the more the soil can absorb water during floods and then provide it to plants in times of drought. So that's how soil carbon storage is extremely important in the context of the water-food nexus. And finally, we want to maximize photosynthetic production because we know that if plants are photosynthesizing efficiently, we can increase biomass production, which is a very important goal. And consequently, we can increase the amount of carbon sequestered in the soil. And that means, you can see here, this picture is going to be important because you can see here that the way we maximize photosynthetic production is not by developing some sort of GMO wheat that can use sunlight to produce wheat for us. That's not how we maximize photosynthetic efficiency. How we do it is we layer the plants to make sure that at every layer there is a leaf absorbing that photosynthetic energy and putting it into the soil. And this requires, by the way, perennial plants and not just annual plants, because annual plants will never maximize photosynthetic efficiency because they are only on the ground for a very short period of time. Okay, so that's the idea of maximizing photosynthetic production. We know nowadays that if we have healthy soil, we have a strong part of what we need to produce food for us in a healthy way. There's a lot more organisms in one handful of soil than there are humans on Earth. So that just gives you a notion of what's going on here in the soil, how important it is for us. And that's maximizing photosynthetic energy makes the land more productive overall, considering all the aspects of the nexus, and that's what we mean by harvesting the sun. So maximizing plant photosynthetic efficiency. Now, what does syntropic agriculture do? It's a strategy that was developed in the past few years with a goal to create new agricultural systems that try to mimic the old, quote unquote, the natural structure of functioning ecosystems, namely functioning forest ecosystems, which we know are very good at providing maximum photosynthetic efficiency. So I'm not going to go through this because I don't want to waste not waste time, but I don't want to go over my time. So I have some slides here on the key strategies of syntropic agriculture. I'm just going to point out a couple of key words in each one of them, and then I will show you the Mertula case, okay? So the key principles, one is layering, as I showed you the picture before, so making sure that all the layers are occupied in the forest. Crop diversity is essential for that. Using trees and perennials, as I mentioned earlier as well. Accelerating ecological succession. If you leave a piece of land for a long time without intervention, eventually, if the conditions are right, climatically of course, there will be a forest, but it takes a long time. So what we do in syntropic agriculture, we try to accelerate that by planting from the start the different layers at the same time. We increase the biodiversity not only in the plants, but also in the types of organisms that can then feed on those plants. And we prune as the regeneration accelerator. So pruning is very important in the first stages of syntropic agriculture. You use fast-growing plants that you can prune, and then the prunings are used to increase organic matter in the soil more quickly, okay? Now let me show you what these people of the Terra Sintrópica Association are doing in Mertula. First of all, I don't know if you know Mertula. If you don't, you should definitely visit because it's one of the most beautiful places in Europe. I agree that Split is very beautiful, of course. Competition. It has nothing to do with it. It's a very, very small town in the south of Portugal. It's in a beautiful location in the river Guadiana. And this is what it looks like for most of the year. It's very, very dry. In the summer, it's very hot, so it's very harsh, and we've done a lot of farming on it, and so this is what we get. For people, for plants, for animals, this is more or less the conditions that life struggles to survive and to thrive in these conditions. We have a lot of extensive cereal farming with extreme loss of soil fertility, plus we have significant amount of droughts. We've had years of 200 millimeters precipitation, which is practically desert, and still the farmers are trying their best to produce something out of this land, but the fields have no trees. They're exposed to the scorching sun for the whole of the summer. There's 45 degrees air temperatures, 60 degrees soil temperature, no plants. You can imagine what this does to the soil life, okay? So what are we doing? What we're doing is we're using this idea of syntropic agriculture where you have the fast-growing plants with all the layers and you're producing agricultural products, annual agricultural products as well in the mix, and in the same climate with very little water intake, and that's very important because of course if you have enough water you can produce as much as you want, but water is a serious constraint. So in the context of very scarce water, you can still produce a lot of biomass. And that's the point. Not everything you see on these photos is edible. Like the poplars are, of course, not edible, but they're very good producing biomass for prunings, and we put it in the soil. We prune it, we put it in the soil, and that helps the plants that we want to get food out of. Okay, so that's the idea. Some more pictures here. After a few years that this has been going on, actually the poplars are much bigger now, but this has been installed about 4 years ago, and it produces a lot of food. And so we can produce and regenerate the land at the same time. So just to finish, this is a slide that shows you the typical nexus trade-off story. You know, so if you want to increase food production, you have to use more land, increase water withdrawal, cut the trees, you know, decrease the land for energy production, whatever. Maybe it's time that we change the way we talk about food production. It is possible to do it in a different way. Do we accept the nexus trade-offs, or do we just say no, there's a different way of doing it, which leads us, instead of all these trade-offs, to create synergies between the different aspects of the nexus? That is, you produce food while you increase soil carbon, while you regenerate the land, while you increase biodiversity, biomass production, and so forth, and decrease water use and increase water quality while you're doing it. So that's, you know, the proposal here, and I hope you'll enjoy that. Mm-hmm.
Thank you. Trying to shift the paradigm, actually, of agriculture understanding. So I want first to ask whether there are questions from the audience. I see that the energy have absorbed all your energies indeed. Yeah? So I have one question which is more related to the scalability actually of the suggested measure, because I'm perhaps doing the devil's lawyer here, but perhaps this type of agriculture might have, as you said, though paradigm shifting, but a limited actually capacity for providing food, but at the same time conserving. So what would be your suggestion on how to include this type of alternative, though needed actually, agricultural practice into a system which demands more and more food and draws actually resources?
The way I see it, the main challenge to scalability is labor. So in the tropics, where this syntropic agriculture idea was developed, so this fits inside a whole paradigm of agroecology, what other people are doing different things, right? But this story called syntropic agriculture was developed in Brazil. And it was developed on a 500-hectare farm. So that's already a pretty big scale. And in Brazil, there are many examples, even of big industrial companies that are using syntropic agriculture in thousands of hectares. So the scalability of the concept itself is not in question. But the difficulty, I think, in Europe is because it's a very complex system, it requires a lot more intervention. It's very difficult to have machines that can do the work very quickly for you, because machines are very good at, if you have one single crop, and then the machine is designed for that, and it just goes and takes the crop. And that's what the machines are good for. And you can't do that in a syntropic farming context. Now, in South America, in Brazil, where they've done this in large scales, they do have a lot of cheap labor. And therefore, it's not such a big deal, because they can actually use the population to produce the food, and it's a very profitable enterprise for them. In Europe, I do think that is going to be a challenge, because to scale up this sort of system for large areas without machinery, it's not very easy to scale up and still have offer competitive produce, right? So I do think it's going to be an issue, but I'm, maybe I'm just being too pessimistic. Maybe it maybe really depends on the crops that you choose. Maybe it is relatively, it's a choice, right? So
from a sustainability perspective would be the socioeconomic aspect, which should be more dig into consideration.
As I can tell you, as a landowner, the reason I started doing this on my land in a very, very small plot just to begin is because I want to make sure that I'm building up soil instead of destroying it.
So you are more towards than the
I'm thinking of the future of my property. I'm thinking about, because you see every year conditions are getting worse. And farmers are surviving because they're getting money from the government. Otherwise, they would not survive. They would not survive in the market. So you're thinking, what are we doing? So we're getting the tractors to go through the fields, and they're not producing anything because it doesn't rain enough. So what are we doing? We're not producing any food either. So sorry, that's the context. You have these large-scale farms, and they're not producing anything either. Because they don't get enough.
And also fertility is reducing quite rapidly.
But maybe we can research more.
I do think we should research more. And I think it is very important that more...
we can optimize this.
That more examples come around, and then we can try to do it better.
Okay, we have stimulated discussion. Please.
Yes. Yeah, thank you very much. Very inspiring talk. I was thinking about, what about the co-benefits? You as an environmental economist, so for instance, couldn't you use the compensation that the benefits for the biodiversity and also for the carbon removal to sort of to scale it also to other benefits that you receive from this kind of syntropic agriculture?
That's a very good comment. I do think there's a lot of potential for the carbon storage, because carbon storage is easier to demonstrate. For the biodiversity, I still don't see, as an economist, I mean, of course, payments for ecosystem services are widely used in different parts of the world, but not so much in food systems. So it's more to protect the sort of natural ecosystems that are there, and we pay for the people to keep them. Now we're creating something that is a completely different ecosystem. This is not a natural ecosystem. It's a very intensively managed ecosystem where we're trying to maximize photosynthesis, but also food production. So the biodiversity aspect, I think, would be a bit more complicated. I do think financing with soil carbon storage is a pretty straightforward way to get more income to these people.